there's a feedback loop. AI designs chips, chips become more efficient, and then the more efficient chips train better AI. Here's Michael, and this is 3 Minutes of AI. Today we want to talk about AlphaChip and how AI is in a feedback loop that is improving chips, which in turn improve AI. This is what Demis wrote in a post on X. And now we want to look at how does this work and what exactly is AlphaChip that makes this happen or this possible. Now, AlphaChip is a result that was recently republished, or the experience gathered and the results gathered were just recently published, but originally was published more than 4 years ago. Now, what is it? So AlphaChip in itself is AI that's trying to optimize chip designs. And it tries to do that by finding optimal placements. And those placements are coming from how circuits are designed. So you usually have components that you need to place on your overall chip design and that are connected to each other. And that means whenever you place something close to each other, there can be a short wire and quick communication, and you need less wire. And if it's further apart, you have a long wire, slower communication. Also, if you place things close together, they might produce heat together. Those are things that you need to consider. It's the power consumption, it's the heating, it's the wires that mean slower or quicker or more power consumption. This is what's coming together in this chip design. And here you see a little animation on how these individual components can be placed on this overall placement. And now what AlphaChip does, how it's now called, is that it's trying to find an optimal placement that reduces all of this. And what exactly is it? This is not an LLM. This is it's an agent though, and it's a reinforcement learning based agent. What we now released is that we give out pre-trained checkpoints where we learned how to do this so others can start quicker by training such placement agents or strategies. And you see, we use this already for our TPU version 5, version 6 now. And it finds very excellent wire lengths, so placing the components very closely together. Now, if you go to GitHub, you find AlphaChip there, and you can use this. And the major work here, I would say, is that they defined an environment, designed it very well, so that you can describe how the placement problem looks like, and also found a good way to express a reward function that looks at power consumption, wire length, and many things, and gives reward if this is very low and very optimal. That's the major work. Because the agent itself is not any specific agent we haven't seen before. So this agent is using PPO, a very popular algorithm for learning with reward. And that's a proximal policy optimization approach that works very well, is usually quite stable in comparison to other reinforcement learning approaches. And this is so old, it's still using TF agents, while in the meanwhile, DeepMind has developed libraries like Acme with pre-implemented PPO agents and so on. While here you find a very specific implementation of PPO, a network, checkpoints that you can load into this PPO agent, and all of the magic is, in my opinion, this whole environment that describes how to do these placements and how to give the reward. Now, the original work was, as I said, this is a post from 2020, and there's even a paper published earlier than that, where you can see how this works and is described in more detail. I'll link this in the description below, of course, and then you can also read this original article. You can find all the details here, and also what it means to have a pre-trained policy, which pretty much helps you save on extra training time and getting to results much quicker. That is pretty much where this helps a lot. You can also read the paper in which all of this described, and the interesting bit I find is how they describe how the reward is working. This is, I think, a very, very interesting read. And this is AlphaChip. It's an RL agent, as you can see, that is very good at finding good chip designs by placing components closely together. And then by that, produce better TPUs, which we use to train AI like AlphaChip. All right, everyone. See you next time at 3 Minutes of AI.